Well, there are variables associated with gases. Two of them are pressure and volume. The pressure of a gas depends in part on its volume. If we keep the temperature the same and the amount of gas the same, the pressure will increase if we decrease the volume. And this makes sense. If we think about squishing a gas, compressing it, it's going to have a higher pressure. If we expand the container, if we increase the volume, that's going to cause the pressure to decrease. And this relationship was studied by a guy named Boyle, and so we call the relationship, the mathematical relationship, Boyle's law. So we can think about a bicycle pump. So there's a one-way valve in the bottom of the bicycle pump, and when you lift the handle up, air is allowed to flow in through that valve. Lifting up the pump, this is essentially a piston. There's this little seal in here, and as you lift it up, it's going to decrease the pressure as you're increasing the volume, and that will cause the air to come in. The one-way valve does not let air go out. The only way the air can go out is through the tube connected to your tire. And when you press down on the pump and you decrease the volume, you increase the pressure, and you send that air into the tire of your bicycle. The relationship between volume and pressure was discovered and studied by Robert Boyle, who lived back in the 1600s. One of the cool things about gases is that you can study their properties with essentially no technology. Electricity hadn't even been discovered yet, and these guys are doing experiments with gases and developing these laws. It's very cool stuff. So what Boyle's law assumes is that you have a constant temperature and a constant number of gas particles. So the amount of gas is the same. You're just changing the pressure and the volume of it. And what Boyle's law says is that the volume of a gas and its pressure are inversely proportional. So we can say the volume is proportional to 1 over the pressure. That means that as the volume goes up, the pressure goes down. When the volume goes down, the pressure goes up. One goes up and one goes down. That's the inverse proportionality. And he did studies with equipment like this. This is a J tube. It's a tube in the shape of a J. And the one arm of this tube is sealed and the other is open. And so there's a gas inside here, and then there's mercury. And he could measure the difference in the pressure by measuring the difference in the heights of the columns of mercury. When this arm is higher, that means that the pressure inside is greater. The pressure of this gas is pushing the mercury down. If both of these ends were open, the mercury levels would be the same because the pressure on both sides is the same. So here he's got a gas sample. He can increase the pressure on that gas by adding more mercury to this side of the tube. The mercury is pulled down by gravity and it squishes the gas. He can still measure the pressure as the difference in the height. So we see here, this gas has a larger volume than this little bit of gas here. But this pressure is smaller than that pressure. And so what he did is he varied the pressure and measured the volume. And then he came up with a graph like this. So pressure is what he was controlling. That's the independent variable. And what he was measuring was the volume of the gas. That's the dependent variable. So what he found was as he increased the pressure, the volume of the gas got smaller and smaller. And there is a mathematical function here. Now that doesn't form a straight line. I thought this was going somewhere else. But if you we'll just come back to that, I think. So let's think about kinetic molecular theory and how this can explain what's going on here. So here we have a picture of a cylinder with a lid that can move, and here we have a small mass on here. Here we have a large mass that's going to press down. Here we have a gauge that's giving us the pressure. So here the pressure is 1 atmosphere. Here the pressure is 2 atmospheres. Same amount of gas in each of these. We've compressed this one, which had a volume of 1 liter, and this one now has a pressure of 0.5 liter. The decrease in volume causes the area inside this to change, the area of the surface, right? So the area has gone down because pressure is force per unit area. So the area has gone down, and we've also increased the number of collisions, because how many are there? 2, 4, 6, 8, 10. 10 molecules in here. And here they have a large volume, a large area of the container to hit. Here they're pushed together. They're going to run into the container more often. Does that make sense? They're in a smaller, confined environment. They're going to run into the walls more frequently. More frequent collisions is more force. So you have more force and smaller area, the pressure is greater. So kinetic molecular theory explains Boyle's law. Boyle's law, being a law, says this is what happens, doesn't explain why. Kinetic molecular theory explains. So the most useful expression of Boyle's law is this: P1 V1 equals P2 V2. So the pressure at one set of conditions times the volume is going to equal the pressure and times the volume at a different set of conditions. Because if this pressure goes up, the volume, if this is large pressure, and that's, just scratch that. Let's just use it. Let's use it because I'm losing it. So we can do problems, and this is going to involve some algebra. So I know some of you aren't going to be happy about that. Someone's allergic to algebra, I think. A cylinder equipped with a movable piston has an applied pressure of 3 atmospheres and a volume of 5 liters. What's the pressure of the cylinder if the volume is decreased to 2 liters? So here we've got a volume of 5, and we're squishing it to make a volume of 2. Is the pressure going to go up or down? The volume gets smaller, the pressure goes up, gets larger. Well, that's nice, but we need to have some numbers. So we're going to use this equation. What we need to do is identify what these numbers are. And I think the best way, in fact I know the best way for most people, is to make a table. So we're going to make a table to organize this information. We're going to have 2 sets of conditions, 1 and 2. So we're going to read through the question again. Cylinder equipped with a movable piston has an applied pressure of 3 atmospheres. There's a number. Let's write it down. 3.0 atmospheres, including the unit. Applied pressure. Okay, they're telling us that's the pressure. If we didn't know, if they didn't say that, then the unit should tell us. Atmosphere is a unit of pressure. 3 atmospheres, and, these go together, a volume of 5 liters. So volume is 5 liters. There's our volume. What? Volume. I'm going to get rid of that. I don't need that. These 2 numbers are together in the problem. They go together. That's the one set of conditions. And then it's asking, what is the pressure? That's our question. What is the pressure if the volume is decreased to 2 liters? 2 liters is another volume. So we're going to put it over here in the volume column, 2.0 liters. The question is, what is the pressure at that volume? So this is what we're trying to find. This is column P, row 2. We're going to call that P2. So we take our information and we organize it, and now we're going to use the equation to solve for P2. So we write down Boyle's law, P1 V1 equals P2 V2. And what we need to do is we need to rearrange this equation so that we can get P2 by itself. This is where the algebra comes in. Well, we've got P2 multiplied by V2. The way we can get rid of it is to divide by it. So this is multiplied. We're going to do the opposite. We're going to divide by V2. Because V2 over V2 equals 1. Poof, goes away. But this is an equality, and so we have to do the same thing to both sides. It's like a teeter-totter, and it's balanced, and we have to keep it balanced. If we're going to put a rock on one side, we have to put a rock on the other side. If we divide one side by V2, we have to divide the other side by V2. So now we have P2 by itself, but it's all kind of messy, and the P2's on the right. So let's just rewrite this. P2 equals P1 V1 over V2. Really, really important to get the subscripts correct and not to mix them up. P1 V1 over V2. Now we can take the numbers from our table and just plug them in. So pressure 1 is 3 atmospheres. Include the units. Volume 1 is 5 liters. And we're going to divide by volume 2, which is 2.0 liters. Then we look at our units, and we see that liters cancel out, and we're left with a unit of atmospheres. And then we do the math. So we have 3 times 5 divided by 2, which comes out to be 7.5, and the unit is atmospheres. And we had predicted that the pressure would go up, and it did. It went from 3 to 7.5. Any questions?